All right, this will be for the con assignment, number of solutions to a system of equations algebraically. All right. So really, there's more than one way to do these. But again, these are both linear or line equations. All right, and I'll show you the three examples. If you have exactly one solution, okay, they're going to have different slope, and that's it, just different slopes. Okay, so exactly one solution for two line or linear equations. All right, you're just going to have two lines, two straight lines, if I can draw it, two straight lines that intersect. Okay, and that point of intersection is going to be your solution. All right. So in order for two lines or two linear equations to have exactly one solution, they have to have different slopes. All right. So for no solutions, they have to have the same slope, but different y-intercept. All right. Let me erase the first one so there's more room. No solutions. Same slope, but different y-intercept. Okay? They're going to have to be two lines that run parallel to each other. Okay? They never intersect. They never meet. In order for that to be true, they have to have the same slope and a different y-intercept. If it were the same slope and the same y-intercept, that would be the same line. Okay? So that's why they have to have a different y-intercept. All right? And now finally, for infinitely many solutions, it has to have the same slope and the same y-intercept. Okay, and basically that means it's the same line. Okay, so it's just going to look like one line, and the same line is going to be on top of it. Okay, and sometimes it's easier to recognize infinitely many solutions because one equation will be a multiple one equation is a multiple of the other. Okay? In other words, if you had an equation, y equals x plus 1, and you multiplied both sides of that equation by 2. So you did 2 times y, and you did 2 times x plus 2. These two equations are exactly the same. Okay, these are the same lines. So this would be infinitely many solutions. You can see one equation is a multiple of the other one. And in that case, it's infinitely many solutions. All right. So for these, there's more than one way to do it. You can attempt to solve for x and y, or you can attempt to get it into y equals mx plus b form. All right, just looking at these two, I can tell one equation is a multiple of the other, like I just said. All right, if you want me to prove it, I'll take the top equation and multiply it by 5. Okay, I'm allowed to do that as long as I do it to both sides of the equal sign. I'm going to multiply both sides of this by 5. So distributing the 5, I have 5 times x. I have 5 times positive y, and put the equal sign, and then 5 times 3. So notice I have the same equation. 5x plus 5y is 15. Okay, it's the same line. that means it's going to be infinite. All right, infinitely many solutions. All right, so I think in a lot of these, it's good to try and attempt to solve for them. All right, and I can tell right away this is going to be no solutions. All right, the reason I know that is because I have 5x minus y on both of them, but the constant term is different. We have a 2 and a negative 2. So I know when you put these in and make them y equals mx plus b, they're going to be parallel, and the y-intercept is going to be different. All right, but again, just to prove it to you, all right, I'll write it a little bigger. 5x minus y equals 2. And over here, 5x minus y equals negative 2. Okay, remember when you have these two equations with two unknowns, you're allowed to add or subtract the equations. All right, what happens if we subtract them? Okay, 5x minus 5x is 0. Negative y minus negative y is the same as negative y plus y, because two negatives in a row make it positive. So that's also going to be 0. And on the right of the equal sign, I have 2 minus negative 2. Okay, the two negatives make it positive, so that's actually 2 plus 2. So I get 0 equals 4. Can we solve that? No, that can never be true. 0 equals 4. So it's no solutions. All right, one more. So let's see. So many ways to do this. All right. Since this one is in the form y equals mx plus b, let's do the same thing with the top equation. Okay, let's solve for y. I'm going to divide both sides by 3. Okay, 3y divided by 3, the 3's cancel. Negative 6x divided by 3 is negative 2x. And positive 9 divided by 3 is positive 3. Okay, and just rewriting the bottom, y equals negative 6x plus 9. Okay, what's the slopes? We have a negative 2 and a negative 6. What happens when you have different slopes? The lines are going to intersect if you have different slopes. They have to. Okay? So it's going to be one solution because different slopes. All right, one more. All right, let's see here. Again, there's so many ways you can do these, all right? So I'm going to try to show you different ways. Let's multiply. We could divide the top one by 5, but just to prove it to you, let's multiply the bottom one by 5. All right? So distributing 5 times y equals 5 times positive 3x, 5 times negative 8. And the top one, just rewrite it. 5y equals 15x minus 40. Okay? I do not have to solve for y. We can already see it's the same line. Okay? It's the exact same equation on both of them. If it's the same line, it's just the same line on top of itself. Okay? So that's infinite. All right, one more just for fun. Last one. Last one. Okay, you can divide the top by 2. You can multiply the bottom by 2. All right, let's solve for y. Since they solve for y here, I'm going to divide both sides by 2. All right, on the left-hand side, the 2's will cancel. And I'm solving for y. 4x over 2 is 2x. 6 over 2 is positive 3. Okay, remember when you divide both sides by 2, each of those terms that are added together get divided by 2. Okay, and on the bottom, y equals 2x plus 6. Okay, same slope. Both of them have a slope of 2, but the y-intercept is different. Okay, so since it's the same slope, they're going to be parallel to each other. All right, as long as the y-intercept is different, it's not going to be the same line. Parallel lines never intersect. So if they don't intersect, it's no solutions.